Hello, this is Dr. Brown. In this video we're going to talk about a concept that helps you take derivatives of composite functions. That means when you're taking derivatives of functions. Sometimes this is a hard concept at first when a student sees it, but I hope by just starting off with some examples and then going into more examples you'll be able to see this concept and that you'll understand it well. Now, basically, to give you an idea of what we're doing here, suppose you have a function and the input is x and the output is y, and it's a composite function. In other words, x goes into first a function g of x, and its output is u equals g of x. And the function could look like this, and obviously it's not a linear function, and it's going to have a derivative, and it's going to vary depending on what x is. And then suppose the output of g of x, which is u, goes into a different function called f of u, and obviously it's not linear either. So in order to calculate dy dx, you have to take into consideration everything that's changing. So a key thing I wanted to say here is you are not finished until you have accounted for every function. That is changing. Therefore, you have to take a derivative for every function that you see. Now, I'm going to start off by just doing an example, and the function is a composite function that equals sine of x to the fifth power. Now, this is not just x to the fifth power, it's sine of x to the fifth power. So you see two functions here, a sine function and a power function. Now, I'm just going to go ahead and work the problem. F prime of x, and we're going to first just consider that what's in parentheses is just plain old x. And so we're going to go ahead and work the problem as if it were plain old x, and we would put down 5. And we would generally put in here x, but since it's not plain old x, we're just going to put sine of x, and we're going to take power minus 1. So we work part of the problem. The answer is going to be comprised of 5 times sine of x to the fourth power. But then we have to multiply by the derivative of sine of x, which is cosine of x. Now I've taken into account all of the functions, and this is the answer. In fact, you could rewrite it if you wanted to as 5 cosine of x times sine of x to the fourth power. So in a nutshell, if you got a function within a function, you treat this inner function, which we're going to call u, and take the derivative as if were plain old x, and then multiply by the derivative of u. And that's what we call the chain rule. On the next page, the chain rule is stated sort of formally. It just says this: is f of u is differentiable at the point u, and u is equal to g of x, and g of x itself is differentiable at x, then the composite function f of g of x is also differentiable at x. And the bottom line is, to calculate dy dx, you first calculate dy du and multiply by du dx. We're going to complete this video by just simply working some problems to illustrate what is going on here. Let's take this composite function, which is a polynomial that's rather complicated, to the 101 power. Now, you could get by without using the chain rule if you had enough time to multiply this inner function out 101 times, and then take the derivative of each component, which would take forever and ever. But with the chain rule, we can write the answer down fairly quickly. The derivative is going to be equal to the power, and we're going to treat the inner product u as if it were plain old x, and just write it down. And it takes a few seconds to do this. To the power minus 1, which will make this to the 100th power. But we're not through. We've got to take the derivative of this u with respect to x and multiply it by what we've already got. And that is obviously going to be 7x to the 6 plus 25x to the 4th plus 63x squared plus 20x, and of course the derivative of 1 is 0. In fact, there is the answer. I was just going to put it over here, but we'll just leave it like that. Now, why don't you pause the video and see if you can figure out how to do this one. I can start you off by saying that you're going to write this as 8x squared plus 3 to the 1/2 power. Now pause the video and see if you can come up with the answer, then come back to the video and see if you got it. Now if you come back to the video, this inner function is what we would call u, and we're going to say that y prime, which is also dy dx, is going to be the power times 8x squared plus 3 to the minus 1/2 power, and that takes care of taking the derivative with respect to the inner function. And now we're going to take the derivative of the inner function and multiply it by what we already have. Well, du dx is just 16x, so we're going to multiply this by 16x, and then as you can see, we can take 1/2 times 16x and get 8x times 8x squared plus 3 to the minus 1/2 power. And now we would write it this way: 8x divided by, we're going to bring the 8x squared plus 3 to the denominator and write it as the square root of 8x squared plus 3. And so this is the answer. Now the next example, I might ask you to go ahead and pause the video and see if you can work this yourself also. In fact, you go ahead and you decide how you're going to rewrite this so that you can use the various rules that you know. Okay, so if you're back, we would write this as y equal x to the minus 1 power plus cosine of x to the 1/2 power. And now we're going to take the derivative. Of course, the derivative of the first part, we don't need the chain rule, we just need the power rule, and that's going to be minus 1, which is a power, times x to the power minus 1, which is going to give us x to the minus 2. Now for the second part, we'll need the chain rule, and we're going to treat this as if it were plain old x or u, and we're going to take 1/2 times cosine of x to the power minus 1, which is minus 1/2, times the derivative of cosine of x, which is minus sine of x. And that's all there is to it. Now we can rewrite some of these portions. The first part would be minus 1 over x squared. We can write the second part as minus sine of x over 2. And also bring the cosine of x to the minus 1/2 power and rewrite it this way as the square root of cosine of x. Now why don't you pause the video right here and see if you can work this problem. Okay, if you're back, notice we've got several functions here. We've got tangent of x plus cosine of x to the 5th power, and we got an exponential function and a sine function up in the exponent. So y prime is going to be the power times tangent of x plus cosine of x to the power minus 1. But now we have to multiply this by the derivative of this inner function u, which is going to be the derivative of tangent of x is secant squared of x, and the derivative of cosine of x is minus sine of x. And then we're going to treat sine of x as if it were just plain old x, and we know the derivative of e to the x is e to the x, so we're going to write down e to the sine of x. But because this was not just plain old x, we have to multiply by the derivative of sine of x, which is cosine of x. So to tell you the truth, we don't really have to write anything else down. If you insisted on it, and maybe one of the answers in the multiple choice might look like this. So you might look out for 5 secant squared of x minus sine of x times tangent of x plus cosine of x all to the 4th power plus cosine of x e to the sine of x. It really doesn't matter. Either one of these would go in your calculator fine if you had to evaluate this function. Now the last example is going to require a little bit more algebra. Why don't you pause this and try to work it yourself and then come back. I'll go ahead and rewrite this so it might be a little bit easier as x times x squared plus 1 to the minus 1/2 power. Now you've got a product, and you'll be using the product rule, and for part of it you'll be using the chain rule also. So go ahead and pause the video and try to work this yourself. Okay, let's work this problem. The derivative using, first of all, the product rule is going to be the first, which is x, times d dx of x squared plus 1 to the minus 1/2 power, plus the second, which is x squared plus 1 to the minus 1/2 power, times the derivative of the first, which is just 1. Derivative of x is 1. Now to get this first portion, to take this derivative, we'll go ahead and write down the x and take the derivative of x squared plus 1 to the minus 1/2 power. And using the chain rule, we're going to take the power, minus 1/2, times x squared plus 1 to the minus 1/2 minus 1, which is minus 3/2. And now we got to remember the chain rule. We have to multiply by the derivative of this inner function, which is going to be 2x. And then, of course, this second portion is just x squared plus 1 to the minus 1/2 power. Now let's simplify some of this. We're going to have x times 2x, which is 2x squared times minus 1/2. So you can see we're going to have minus x squared. And I'm going to go ahead and put x squared plus 1 to the 3/2 power, the positive 3/2 power, in the denominator, and add to that x squared plus 1 to the minus 1/2 power. Now I'm going to combine these two, and you remember a over b plus c over d is ad plus bc over bd. So we're going to do this cross multiplication here and get minus x squared, and we're going to get x squared plus 1 to the 3/2 times x squared plus 1 to the minus 1/2, which makes it a little easier for us. That's just going to be x squared plus 1 to the 1 power, and the denominator is going to be x squared plus 1 to the 3/2 power. And notice minus x squared plus x squared cancels out the x squares, and we get the answer to be 1 over x squared plus 1 to the 3 power is the derivative. And that is what we're going to finish this off now. Just go back and work as many problems as you can. But this is an introduction to the chain rule, and the key to it is work as many problems as you can.